Hello and welcome. This is the Python version of m3t1. You're welcome to do this program either in C++ or Python, and indeed I provide the code for both. In this case, I want to look briefly at the pseudocode. The pseudocode looks very similar to Python. It's a bit of a simplification because it's not being exact, and it uses some curly braces, which is more of a C++ type of code. But the idea behind selection sort, again, if you didn't watch the other video, here we just kind of get into this explanation. Let's look at the Python version of this code. It's quite short. This is the actual method itself. And what happens, let's say you have a hand of cards. Here these numbers are very large. So you might rather than use a pack of playing cards, you might say take some index cards and put numbers on them. But if you're playing cards, and let's say my hand is 8, 9, 2, 4, 3. Well, I take the 2, I put it on the left-hand side. Then I take the 3, put it next to the 2. 4 next to the 3, and so forth. And by the end of that series of swapping the cards around, my cards go 2, 3, 4, 5, 6, 7, 8. That's selection sort. We have the algorithm here, and then we have a piece of code which calls the algorithm. The program in C++ is quite a bit longer, because it takes about 10 lines of code to just replicate this one line of code in Python. Because in Python, you can print a list. You don't need to iterate through the list. So having said that, I can see that my code is quite long in C++. I'm going to now open up my Python version. And let's see here. Great. And in this case, let's look at what the assignment asks. I ask you to either add some debug statements or allow the user to enter their own array or list in the case of Python. I'm going to show you how to do the first one, to add the debug statements. Now remember, the reason you want to have debug statements is when a piece of code does several steps, or many steps in the case of, say, sorting a list, you want to make sure it's working, and so you may need to step through line by line to see what's actually happening. Okay, so here I see my selection sort. Let's go to the top of this code and add our typical comments. I'll actually do it like this. This is kind of a convenient thing to do in Python. csc249, data structures, m3t1, selection sort. That's the Python version. My name and the date. And of course, you use actual values. So again, here in the selection sort, it's going to find the smallest element. It's going to put it on the left by swapping it with whatever element with the smallest element. And then once the first element is sorted, you ignore that first element. So now you sort of pretend the list is one shorter. I'll show you what I mean when we run the code itself. Now we're going to run this code quickly, make sure it works, and then what we're going to do is we're going to add these debug statements. So you'll want to put a proper header and follow along with what I do in this video, and that'll be m3t1. Let's if I can get my program to run. There we go. Good. Okay. And that just did it all in one step, so we don't really see what happened. But you can sort of see, first it found the 2, put it on the left. Then it found the 4, put it next to the 2. Found the 7, put it next to the 4, and so forth. That's selection sort. It's sort of a pretty intuitive algorithm. Now let's look at what's happening here. Okay. So now the things I want to find, well, first of all, what I might want to do is each time through, I'll also note here, I took out this comparisons. We're not actually doing this comparison yet. This will be later in the lab when we actually try to count up the math of how many times are we actually swapping values and how many times are we comparing numbers to try to find the big O values. Okay, so now I'm going to put a little comment here and just say, in this case, let me get my tabs correct because I didn't quite get that right. So good. We've found the smallest value this pass. Again, the first pass it's 2, then it's 4, and so forth. And I'm going to correct my tab order. One thing you're going to find if you copy and paste code into Replit or into Anaconda or even Idle, the tabs are going to give you fits. So you're going to want to fix your tabs manually. So I will print here. I'm going to put a tab in here. Smallest. And I'm going to put the value, which is j, at index at j. And the value is actually numbers j. So for example, I would say 2 at 1, because this is the 0th element, this is the 1th element, the first element, right? Those are the index 0, index 1. So this should print smallest 2 at whatever, smallest 4 at whatever. So that will help us see if each step is happening. Sorry, I keep right-clicking. I apologize. Smallest 2 at 1, 4, 10, and 3. Now, this is every time it goes through, so it's not finding the smallest one. You know, it actually 7 is the smallest one at this point. So this doesn't tell us much, so we need to add a little bit more code. The other thing we want to do is to say that we're swapping some values. Okay. Print, we're going to say swap. Let's again put a tab here. We'll say numbers. And okay, that should be right. Let's see if this is correct. So it should say found 2, swapping 10 and 2, and it did. You know, so then it finds 4, swaps 10 and 4. So now it's 2, 4, and so forth. Now what I need to do here is each time through, we're going to do a little quick statement here, and we'll say, well, this is going to be a little annoying. Let's fix my tabs. Okay, great. Numbers. Debug code. And we're gonna turn this debug code on and off in a moment. Let's look at how this looks. So part sorted 2, 10, 4, so smallest 4 at 3. It does that every time, so we don't want to do that. What I want to do here instead is do it at this point, because I only need to print it once per pass. There we go. So now what should happen is it should say, cool, so here's my list unsorted, and now I find values 2, and I swap 10 and 2, so now I see 2, 10, and so forth. So there's so this part's now sorted, so I can ignore the 2. So then I find, what's the remaining smallest one? Well, it's 4. Well, 4 is at index 3, which is the 4th element, right? 0, 1, 2, 3. Swap, so then it has these values, and it finds 10, but then that's not the smallest, 7's the smallest. Swaps these values, now it's 2, 4, 7. And so you can see as you go forth, you're partitioning a list into the left-hand side, which is sorted, and the right-hand side, which is not yet sorted. And by the time we get to the end, there we go. So this sort of shows you what's happening on each step. The last thing I want to do is I want to add a bit of debug code. I want a debug flag. Okay, what does that mean? Well, let's just say here debug equals true. So now I don't want to print this code out unless I have debug turned on. So I'll say if debug, same thing here, if debug, and then finally again if debug. So, you know, every time well, I better fix this tab here, right? There we go, good. So now, and the reason is because, well, when I run it now, it's going to give me all this debug code. But then when I actually ship this to the user, they're going to find that very irritating. So I'm going to turn it off. I keep mixing my code here. I'll stick it to Python. With debug false, all those lines are now not printed. Okay, this is a very useful technique. You don't want to go through and have to comment out all this debug code every time. You want to be able to easily turn it on and off. There's other techniques you could use, but this is sort of the easiest way to start. So now you could add user input to reading the list, but we'll wait on that. We'll just go with this version. Again, to save the program to what you're going to download, the main.py, you're going to turn that file in for m3t1. All right, thank you very much.